me, I started recording, and we are starting the 45th meetup, San Diego C++ meetup, and I'm gonna just go over the regular slide just to present the agenda first. So just the regular welcome slides, and we have a special guest today, Amir Kirsh, that would give us a presentation about Move. I'm super excited to have Amir again in our meetup, and this is an exciting um, uh, feature in C++ that we all need to be more aware of and know how to use it well. So looking forward for this presentation. If we have time, I have like 5.5 slides about polymorphic arrays and the issues behind polymorphic arrays. So just if we have time, we'll have another 5 minutes of that. If not, we'll have it next time, which is going to be in next year in January. Um, Again, if you want to present in our meetup, feel free to approach me, and I'll be very happy to have you. Uh, any topic. There's like millions of stuff that we can have in C++. It would never end. So I can help you if you need a topic, and if you want to have any from few minutes lightning talks to 1 hour and beyond, just let me know. This is sponsored by Qualcomm, the WRD software, which I'm part of. We have a Dropbox where we put our slides in. We have a Slack channel. We have Discord. I'm actually using Discord more than the Slack channel. We have a YouTube channel that we uploading our sessions, and we also have our uh, Twitter handle, and also my handle is listed here as well. Um, I have a blog, a part of the blog that Martin actually owning. I have a page there. Sometimes I'll put some of my thoughts, and I also publish the results. Basically, publish the sessions that we have in every month in the San Diego Spurs meetup. Okay, without further ado, let me introduce our guest, Amir Kirsh. He's a dev advocate in Incredibuild, C++ lecturer in the Academic College of Tel-Aviv-Yaffo, and he's visiting researcher at Stony Brook University, which is in the East Coast, right? I'm not super familiar with this area, but he's a co-organizer of Core C++ conference, which I heard is a very, very good conference, which just didn't have a chance to attend yet, but that's also on my bucket list. Uh, Amir Kirsh used to be my teacher back in '98. I owe Amir a lot of my passion about C++. I still remember his classes, and it's still a very fresh memory even after 23 years. Um, so Amir, everything that the stage is yours. I'll stop
Thank you.
sharing.
Thank you. Uh, so hello, everybody. I will share my screen in a moment. Uh, you should see my presentation. So I think that now you see my
Yes,
presentation.
yes, we can
I'm
see it.
trying to bring Teams to the other screen. Let me see that I can do that. Yeah, it is possible, I guess. So I can see you as well. Yes, that's good. Okay, so I'm going to speak about move semantics as Kobe presented. And Kobe, thank you for the introduction. It was many years ago. I was a bit younger. It was when I started teaching, and I'm still teaching C++. And I see that move semantics is a bit problematic. I mean, eventually you get that, and still at certain points you stop for a moment and ask yourself, should I move here, or maybe should I not? And this is what I want to do with you. It is going to be an interactive session, so please be prepared. I need your attention. There are going to be questions, and you would have to look at some code and to come up with an answer. And the best thing is do we have a chat here, Kobe?
Yes, we do. I don't know if
Uh,
everyone has access, but we
I'm
do.
not sure that I see the chat.
Yeah, maybe because you don't have access to the main one, but
Okay, to the Teams
just
account. Anyhow, if
yeah.
most of the participants have access to the chat, the best way is to just post your answer in the chat, and then we can see that what do you think, and then we can discuss. But it is much more contributing to you, I think, to actually cast a vote instead of think about that, because you are committed to I thought about that, and oh, now I see that maybe I was right or wrong, and it is better than just to have your answer in your head. So I think that I would start with a short introduction, which Kobe already did, but I'm a lecturer at the Academic College of Tel-Aviv-Yaffo and Tel-Aviv-University, a visiting lecturer and researcher at Stony Brook University, Long Island, East Coast, a developer advocate at Incredibuild, a member of the Israeli ISO C++ national body. We discuss proposals in order to give some notes and notions to the ISO committee, co-organizer of the core CPP, Meetup group, and conference. A few slides about Incredibuild. We do build acceleration by distributing builds to the cloud or to on-prem idle machines. It is important. I mean, at the end, it is the question of your productivity. So if you suffer from slow builds, don't hesitate. Talk to me. You would have my email at the end, or you can ask Kobe, or you can find me. We recently invested a lot in the automotive, specifically in embedded Linux. So if you are in embedded Linux for automotive or for any other usage, again, this is something that we accelerate. We do a good job there. And if you're there, please talk to me. And I think that we are able to go now to move semantics. So the motivation for move, I think, is clear, but let's start from there. Suppose that we have a Godzilla, and I'm using a Godzilla as an example for a class that is quite heavy, is quite expensive to copy. And let's assume that we have a factory. It might be a global variable. It might be that we are inside a class, and this is a factory which is a member of the class. And this factory can create Godzillas. So calling the create frightening Godzilla function would get back a Godzilla. We can see that it would most probably get back something that is created locally in the function. And then when it is created locally in the function, we actually copy it to G1, but then the local object that was created inside the function is dead. So eventually we create an object, we get it back by value, we copy it, and the original object is dead, which is not so efficient because we could have, in a way, used the assets that were part of the object that is here. Instead of copying them, maybe we could use them. And this is the idea of move. Maybe we can use the object here. The object will die. We cannot, unless we have optimization that would allow the creation of the object directly on G1. We would call such optimization return value optimization. But suppose that the optimization is not allowed or the compiler cannot do that. By the way, since C++ 17, in some cases, the compiler is obliged to do. It is a mandatory copy elision. But in some cases, the compiler is not cannot do such an optimization. And the object is being created, and it would die because it's a local object being created in the function. So we cannot actually take that object if there isn't any optimization, but we can still take its assets. When I say take its assets, I mean we can actually, suppose that we have pointers that point to allocations, we can take the pointers and do shallow copy, which means, okay, instead of allocating on the other side on G1 and copying the content, we can just copy the pointer. And then we need still to do something very important to come to the object that is going to die and put null PTRs inside that one pointers to avoid any destruction on the allocations that were made on this side. So eventually we can move the assets to G1. In some cases, I call it to steal the values or the assets from the right side. Also for G2, we created G2, and then we can get a spooky Godzilla from the factory. And this spooky Godzilla is also a local variable that was created here. And instead of copying that through the copy assignment operator, maybe we can move it. And then the last example here is calling pushback. When we call pushback, we have here a temporary object. Instead of creating the temporary object, copying it, we can create the temporary object on this side and then move it into the list. By the way, what other solution do we have instead of creating a temporary and then copying? I mean, moving it is a possibility, but there is another option that might be even better.
Maybe in place.
Yes, we could use in place. So we could have used in place back instead of pushback, and then we would not create the temporary object like that. We would just send the uh, parameter to the constructor, like the sweetie const char star, that would then be passed to the list, and the object would be created on the callee side and not on the caller side, inside directly inside the container. But here, for some reason, we add the temporary object and we pass the temporary object, and there isn't any need for creating it here and then copying. We can create it and then move from that. So the idea behind move is clear, and C+11 added move. And then the question is, in some cases, we need to stud move, and let's see what happens if we do not. Okay, so the first question, and this is going to be interactive, as I said, is suppose that we have two constructors for A, class A, this one that gets a string by value, and we do something with this string by value, and another one that take a string by R value reference, this double ref here is an R value reference, and again, tries to take it into the member name. Would we see move or copy in any one of them? And the answers are copy in A, move in B, copy in B, move in A, copy in both, or move in both. Please cast your votes.
So you want us to cast it in the chat or
I
people
think that
shout?
you can shout your answers. This can go as well.
Okay, people can shout. I have my opinion.
I can approach, randomly some
So
people here.
someone said, so
It's on the
Nilesh
chat.
said yes. Yeah, people put stuff on.
So you can please you can share.
Okay,
What do you
so
see there?
Nilesh says A. I actually says I say B. And I'll explain why I think it not B. Sorry, I meant C. Copy in
Mm-hmm.
both. The reason copy in both is that I think the first one is kind of obvious. The second one is not really obvious. Even though it's coming from an R value, inside it already has a name, so it's not an R value anymore. We actually, if we want to have the move constructor, let's say name is a stud string as well, we actually need to stud move B name, as far as my understanding at least.
I think that you are right. At least this is my answer as well. So it is going to be copy in both, and the reason is that we are not using std move, stud move, and there is a need for stud move, and stud move is required when you need to take something which you want the move operation to be performed, but the variable sent as a name already, and b name as well as a name as a name. And once a variable has a name, it cannot be moved from because we may use it later on. So since we may use b name or a name inside the curly brackets, inside the function, wherever we want, because we still have its name, the compiler is not allowed to move from it. So there is a rule saying that although we got it as an R value, and although if we would ask, what is your type? It would say, oh, I was born as an R value, but I am treated by the compiler as an L value reference. So I'm an R value. B name knows that, but I'm treated as an L value because I have a name. Okay, so there would be copy in both, and this is why we have stud move. So we in both cases it might be that we want to move in both cases. This one is because we got by value. By value means that you did not get the original object, you got a copy, and the copy is yours. So if you are not going to use the copy here, you are just going to use the member, then you can move from a name. The same thing is here. You got an R value. Now, there is a difference between the two functions. The first one can accommodate both L value and R value. If you are sending L value to a constructor, you can get in because L value can be sent as by value. You would get a copy. That's fine. R value can also be sent here. By the way, the compiler would do optimization, and instead of copying the R value in, you would just send the R value as is without copying. This is optimization that the compiler can do. In both cases, you can move from that. On the other hand, the second one that expects an R value reference would not be willing to take L value because L value is not willing to get into a function that expects an R value. The compilation error would be cannot bind L value to an R value. And the reason is that, the L value being sent heard some rumor that this function may steal. He heard that somebody went in and got out without one kidney, or stories like that. You can never know. And he says, no, I don't want to go there. They are stealing things. I'm not going there. So L value would not go here. You can go here because it is a copy. In both cases, if you get that and you are not using it anymore, you can move. But you need to call std_move. Now, std_move doesn't move. Std_move just performs casting to our value, preserving casting. It is a preserving casting because it preserves the constness and volatileness. So it is preserving const volatile. If the original value was const, then it is still const, in which case it is not. So I'm not const, but it casts me the A name to our value or B name to our value. Now, this does not do the actual move. The actual move is by assigning the value or sending the value to name, which in this case, if name is a stud string, this is by calling the move constructor of string. So I'm casting to our value, calling move constructor. Casting to our value here as well, calling to the move constructor. Without the casting to our value, I would be calling, like in the previous slide, the copy constructor. But I do want to call the move constructor. So in both cases, I need the std_move. Feel free to ask questions or to discuss. It's an open discussion.
Yeah, I have a comment. It's actually a very good example, especially the first line, because we are at least coming from older C++, the pre-modern. Now we are in a post-modern C++, right? C++ 23 almost. But in a very old C++ 98 and 03, we used to have a const by reference. For example, this is a very common constructor. We get a name. And if you're using clang tidy, or if you're using C-Lion has clang tidy built in, you'll see it highlighting your const reference to string and telling you pass by value and move. And it actually has a button that says fix. And it would create the code that we see here on the first line. This is why it's really important for us to understand that. I have another comment that, and Amir, I want to hear your thoughts. So std_string has this small string optimization. So if it fits into the small string optimization, there is no, like, the move would be actually somehow a copy because there is no allocation, so we can't really steal the guts. It's pretty much a copy. But we still, I think this idiom that is shown on the first line and is proposed by clang tidy, I think this is a good idiom. I actually completely moved into this. Sorry for the pun, but I moved to this first idiom. Unless there are use cases when you say, okay, should not do that.
I would discuss that as well, following in some of the following slides. I would tell all that, yes, this is a very common idiom saying, oh, pass by value if you want to copy. By the way, pass by value if you want to copy. If you just want to read, don't pass by value, because still passing a const reference just in order to read the value would be more efficient. But then I would add that our Dinant is the man behind our value and move semantics. Our Dinant is the man that invented this and pushed it into C+11 as a presentation, I think, given in given in 2014 in Meeting C++ in Berlin or one of these conferences. And he says there, don't use this approach. Instead, you should have two functions, one for the R value and one for the L value. By the way, we discussed pushback. This is what pushback does. Pushback could have say, I'm getting by value, and inside I'm moving from. Pushback didn't do that. Pushback the library implement two pushbacks, one for R value and one for L value. And the reason, even though eventually I want to copy, that I prefer, or our Dinant prefers, and I'm with him, I get the point, is that if you take a look at what actually happens, then for the R value case, this would be efficient. For the L value case, you would find out that you do both copy and move again. Now, suppose that the move is not so cheap. Then you would find out that for L value reference, you copy when you go inside and then you move again, and it might be a bit costly. So our ordinance says, oh, eventually I prefer just to copy and not move and copy. And this is why he says, okay, you should implement both. Now, in some cases, you cannot implement both. And can you tell me a reason why I cannot implement both the L value and R value? And I have to say, okay, I would then go for the get by value as a fallback, as a good fallback. I want to copy strings or strings, and I say, okay, I will take by value.
So I'm thinking about a class type or struct type that doesn't have maybe. So if you don't have, let's say, a copy constructor, you're only a movable one, so you can't really implement a copy.
Okay, let's assume that you have both, but if you implement something for a generic type or like pushback, then you say, okay, I'm having both, and you can select whatever you want. But eventually, I'm proposing both options. So the reason that in some cases you cannot, or it is quite complicated to do that, is if you get more than a single string. Suppose that you have a function that gets 4 strings and needs to copy all 4. So you don't know which of the 4 would be passed as an R value and which would be passed as an L value. If you want to accommodate all cases, it would be 2 to the power 4 options. You are not going to do that. So another option is to have setters. Like, okay, I'm not getting all 4 strings together. I'm getting a 1, and then I'm getting the other. So I have 4 functions times 2 for the L value and R value, but I'm having a set or update for each of the strings alone. But if you have a one function that gets all 4 strings, then I would say, okay, get it by value. Why? If you want to copy, again, if your aim is to get the strings and copy them, then it would be more efficient to get all 4 strings by value and then move from them rather than getting them as a const reference, because it would accommodate both the R value cases and the L value cases without knowing in advance which is which. But if it is one, I would say, yeah, I mean, our Dinan says, who am I to argue with him? He says, have the 2 options. Anyhow, it is, if you know that your movie is very cheap, it is not so bad. It's okay. But what he says is that you can never know. In some cases, the movie is not so cheap. Like, for example, maybe for the string, the addition in percentage, if it is a small string optimization, might be in a very hot loop. It might be something that you want to avoid. So you want only one copy and not a copy and a move. Okay, this was some
Uh,
discussion about this idiom,
Amir,
which again is good, but you have to know its costs. Yes, a question or a comment.
uh, here's a question. Sorry for the amateur question. So, what's the difference between a copy and a move in terms of a memory implication? Copy means you're going to copy it like field by field, but what does move do?
So maybe in order, this is something that we can do on the side. I would, for a moment, just let me know if you would see my screen. I would, for a moment, open, let's say, Compiler Explorer. Okay, Compiler Explorer, and let me know if you see that. Do you see my Compiler Explorer?
Yeah, we can
Okay,
see the tab.
and let's implement something with move. Okay, so suppose that I have a class. Let's call it my string. Okay, and I want to, and my string has inside some size t size and has some char star string. Okay, now copy is very simple. We know what a copy is, but let's just implement some things. Just I would have a single include, so size t would come with this include iostream, for example. So size t, yeah, okay. So if I have the constructor for my string, so I think that I can have a single, the first constructor would be the one that gets const char star s, right? Maybe I have a default, and then it says, okay, for the size, I would give the strlen of s, right? And for the str, I can give a new char of size +1. And then I can actually copy the string that I got. What is the best way to copy the string that we got? Any suggestion?
str and cpy so that it's
Yeah, we can do str and cpy, but I prefer to do, I would tell you what, mem
Copy?
cpy,
Oh,
mem copy. Why? Because any call to str copy or str copy requires the loop to check whether we reached the null terminator. And we know here where is the null terminator. We know that, right? So since we know where is the null terminator, what is the problem size? Size is initialized here. No, I think the size is initialized here. Something is quite, I just want to make sure size is here, is first, size is here. Oh, I have a problem with strlen. This is the case. I just need to probably add and include. I think
yeah.
that strlen come from C string, and
See,
now
yeah.
this would be resolved, and then this would be also resolved. Let me see. Yeah, both. Okay, so memcpy, I want to copy to str, I want to copy s, and I know that the size is size +1 because I want to copy the backslash 0 as well. Okay, so I have this constructor. Now I need to create a few more. Then let's implement the copy constructor. Although the copy constructor would be you're getting a const my string s. Okay, the size. I know the size. I don't need to calculate the size. The size is going to be s size. I would do the same thing here, and I can do the same mcopy here. So I'm copying to s the str. Now this is copy paste of code, which I don't like so much, but okay, we can live with that for this exercise. Now would come the move. Here we actually add a deep copy. This is deep copy. The move would say, okay, I'm taking a reference that the compiler decided to send here because the compiler saw that this is a reference to a dead object or to an object that is going to die in a moment, a temporary object. Okay, the compiler realized that this is an R value reference. So in which case I'm saying, okay, I will take your size, but I would not create a location. I would just take your pointer. That's it. Because I know that you are not going to use this pointer, but I do need something. I must make sure that you would not release your pointer. So I would put inside your pointer null ptr. Now you can ask, where do you release my pointer? Oh, I should release your pointer. I should have a distractor. So with a distractor, I should have a delete of str, right? And the same as these two, I can have two for the assignment. We can do that very quickly. Do you see that? The
Yeah.
difference between deep copy here and the shallow copy, but preserving the value, so making sure that it would not be released. I can put it to do implement. We call it copy assignment and move assignment. In the past, we just called it assignment, but now we have two, so we have to call them with names. So it would be copy assignment and move assignment. The copy assignment would have a signature like that. It would return my string. It would be called operator equal or operator assignment. And I would just put equals delete for now. It is deleted anyhow. It is implicitly deleted because once I implemented the move operation, all the others are being deleted unless I implement them. This is the rule of 5. I'm touching a few things you can write down. I would not cover it all, but rule of 5 says that, well, implicitly deleted anyhow. Okay, but I just wanted to say delete, so you can then implement that if you want. And then I have the other one. So this is the move and this is the copy, and I can put them. Let's put them below the distractor. For some reason I prefer. Okay, so this is how it looks like.
So I have another question. So
Yeah, sure.
if we have object reference being passed instead of a value, which is an L value, we will be using only the copy. We wouldn't be using a move in that case.
Okay, so we can actually practice that. We can actually say, okay, let's assume that we have a my string. Okay, let's call it S, and this would be S1. Let's put a low. Okay, and now I want to create S2, and S2. If I say S2, u equal to a temporary object, I would not be able to do that. I mean, the compiler would do some optimization. If I say, okay, you get world, so it seems that, I mean, if I have, let's have two examples. This one is the constructor that takes char star. This presumably should be the constructor that the move constructor, and the third one that takes S2 presumably should be the copy constructor. So this would be the copy constructor, but this one would be the constructor that takes char star because the compiler would do optimization. And since C+17, it is a mandatory optimization, mandatory copy elision, which means it is not optimization. The compiler is obliged to do that, and it would just call the regular constructor. I can show you that. How can I show you that? I would have a print. I would add a few printouts. So let's add here std_cout sang in the constructor for char star, right? With, and I would print what I have here. I can actually print s. Okay, and I can print the others as well. So here I would say in the, this one is the copy constructor, right? For with, and here I want to print s.str. And the last one is this one in move constructor, but here I don't want to print s.str because s.str is already null ptr. Actually, I can print str. And also here I can print str. It's the same. It's my string. So I think that now we would see, I have some missing semicolon somewhere. Yeah. Oh, in all printouts. I'm a bit reckless. Okay, let's add all semicolons. Okay, so now I think that we have the proper printouts. So we have here in constructor for char star with hello, in constructor with char star for world. And again, this is because the compiler says, oh, you know what? I would not create a temporary object and then pass it. I would just create directly S2. And the last one is the copy constructor. If I want to see this one as a move, I can do the following. Bear with me for a moment. I can say, you know what? Let's do it with C+14. Why? Because in C+14, it was not a mandatory copy elision. Oh, it doesn't change anything. Okay, so let's add a flag -f, no elide constructors, which tells the compiler, please do not remove any call to constructors. And then I have a move constructor with hello. Why? Because of the equality here. It is not the same as passing it with brackets. So passing with brackets would be less operations. Just because I asked the compiler -f no elide constructor. So now hello is direct, but world creates the temporary. The temporary is created on the right side. Then the temporary is being moved. So here we see move eventually. Now, if we are not in C+14, if I'm in 20, for example, then the -f no elide constructors would not have any effect because the compiler say, but I'm obliged to. I have to do that. And I say, but please, you said, but you know, it is the specification that requires me to do this copy elision. In which case, I can still do something like, watch for a moment, std move. I can tell the compiler, you know what? Let's assume that I don't send you. I mean, I send the temporary directly through std move. So here, I send this one to a function. Std move is a function, and the compiler doesn't have any choice but to go to the function. And then, okay, the temporary is being born because it need to be sent to a function. There isn't any elision on call to a function. There is elision. The compiler can avoid calling a constructor if it is according to the spec, but it cannot avoid calling a function. So I call move, I create something, and then the R value gets in, and then I do see the move, even if I'm in C+20. It was very long. Sorry for that, but the question was in place. I mean, we needed that. So if you have any other question, please do so. Do you see the difference here? I will just keep it here as that.
I was going to ask. I thought it was. I thought it was against the rules that we're not guaranteed. You know, you're initializing size first and then string. I thought it's not guaranteed which field will get initialized first.
It is guaranteed. It is according to the order in the class itself. So since size is first, size would be initialized first. Even if I turn the order around, like suppose that I turn the order now, then I'm in troubles. Why I'm in trouble? Because and I get an actual warning of that. Oh, an error in this case. Maybe because I'm with. No, it's a warning. It's a warning. And the result it does work for some silly reason, because for some reason, but it didn't initialize it correctly. So it says, oh, you would not be initialized in the actual order that you think that you are initializing, which is bad. So I would put it. So usually when I do that and I rely on the order, first I check that the order is right, and then I make sure that I don't get any warning. If I get warnings, I try to fix them. Okay, I can press share. I can share it later on. So let's share it. Okay, it means that I have now the link, and we can go back to the slides. I would press slideshow. Just let me know if you see it is a slideshow.
Yeah.
Okay, that's good.
Yeah.
So we can go now to the next one. We discussed this one. Next question. Suppose that we have a constructor for some class A that gets a string and it gets it as a L value reference. But then I'm doing a stud move. I mean, I'm in the copy, but I'm moving. Would at the end, would we see a call to move on stud string on string or a call to copy? What do you say? This is the time to cast your votes. Don't worry, you can guess.
Cast a vote or shout.
You can shout.
I'll tell you.
But Kobe, wait a moment. Let people maybe cast their votes in the chat, so you can be the moderator.
I'm watching the chat.
The answers.
I'm watching the chat. People can just A, B, C, or D. Just put your guess.
You can put
Educated
a reason.
Guess.
You can put a reason in the chat if you want. So I can like focus you on the issue here. We got an L value reference. We're trying to move. I don't know if it is okay or not. Probably it is not. But then the question is whether we would see an actual move, and then it might be maybe a crash if you actually move here, or maybe it would copy. If it copies, why? The comment says, note that above is bad. You should not move here because I got an L value. Why do I move here? But what would happen if you accidentally do that? Kobe, what do you see in the chat?
So someone said D, another one said undefined reference, runtime error, another one says C.
And what is your answer?
My answer?
Yeah.
I'll say the following. If you think about it, move change the object that we move. It's like actually the stud move doesn't do anything. You just cast it.
That's correct. Stud move just casts.
Just cast it, right?
Does a casting to our value. The casting would try to happen here.
Yeah, but the whole idea of move, not the whole idea, but one of the ideas, I don't know if it's the whole, but one of the is that we actually mutating the incoming one. So can we do that with a const? So basically, it would be it would be like a cast to R value from a const L value, and I don't think this should be allowed.
So when you say should not be allowed,
I think it's not gonna be. It's not. It should not compile.
Okay, you say
hopefully.
D. So the answer is B. It would copy, and I would explain why.
Okay.
Stud move would do the casting, but the casting would be to a const R value. Let me remind you, I just said that before. Stud move is casting. It is a preserving constness and volatileness. So if you're const, you are still const. But I ask you to be an R value, const R value. Now, string didn't implement any constructor expecting const R value, because there isn't any reason for that. I mean, what can you do with the const R value? You cannot steal from that, because as Kobe said, in order to steal from an object, you need to put null PTR in its pointers, which I cannot do if I got a const one. So there isn't any implementation for const R value, but const R value can go to the copy constructor. This is the fallback. The copy constructor is the fallback for all operations because it can take anything. So eventually you would go to the copy. Now, do not do that. I mean, do not move on something that should not be moved from. Don't do that. Do not rely on, oh, but I did that and it works. Yeah, it would copy. But this is a fallback that you should not rely on. You should not move in such a case where you got an L value reference and I should copy from it. So, but it would compile and it would, in a way, I would say it would rescue you without even knowing that. But don't do that. So if you want, we can take a look at the table. This is from Stack Overflow. If I send an L value to each one of these functions, it can go to the first one or the second one. It prefers the first one. It cannot go to the R value cases because it's an L value. But if both the L value and const L value appear, then it would prefer the L value because it is without const. I prefer this one. But if this one is not there, I'm okay going to the const version. You can see that the const version can take all possible cases. By the way, const R value is very rare. There is a question in Stack Overflow. Is there any reason for creating a const R value function? And the one answering that is our Dinant. And he says, well, there is something. Okay. But eventually, no, in most cases, you would not have that. By the way, you would not have also a const R value in most cases. Why? Because usually an R value is a temporary object being created by the programmer creating a temporary object. It is quite rare to create a temporary object as const. You should avoid that because then if you do that, you would not go to the R value case, to the move constructor that you want, and this is not so good. Anyhow, the copy constructor signature takes it all. So you can use this table. It comes from Stack Overflow. It is quite useful. Let's go to the next one. I just said that in the previous example, the move here is bad. No, you shouldn't move from something that the user sent you in order to read, not to override. Well, the const in a way protects the variable, but you shouldn't move. Then comes the question, is there a valid case where I can still move from an L value reference? By the way, this is an L value reference, even though it is a template. Yeah, it is the template, but it is still an L value reference. If there would be two ampersands, then it would be something else, and we would discuss it in a moment. But in this case, maybe it will not compile because we are trying to move from an L value. We just discussed it in the previous slide. It compiles eventually. The compiler say, yeah, I will do the casting. Then the question, what would happen? Maybe it would compile with a warning, or it will compile, but it's undefined behavior, or yes, it can be legitimate in some cases. What do you say? This is the time to cast your vote. Bobby is waiting for your votes.
Yeah, I'm looking at the chat. Okay, so C, one person says C, which is it will compile but undefined. It's an undefined behavior.
Okay. The question, by the way, is very generic. You may create undefined behavior with such a thing. The question is, would there be a scenario, a use case in which it would not be undefined behavior and it would be legitimate, in which case it is D? Or maybe it would compile with a warning, maybe because it's C. So maybe it's B and C together. Or maybe it would not compile.
Isn't this depends on the use case? Like if A that was passed as an argument to as a parameter, if no one is using it after it's being passed,
how can I know that? How can I know that A would not be used? I cannot know because somebody sent me an A, and I'm saying, okay, let's steal A. The user, the caller, may use A. It was, and then the question is there any use case that would allow for the answer D? D says, yeah, in some cases it may be okay, and the answer is. Kobe, what do you see in the chat?
I don't think it's an undefined behavior because it would be an undefined behavior even only if I'm continue to use the parameter but the argument.
When I say undefined behavior, it means that I cannot know what happens on the caller side. And it might be that the caller is using A, so in which case, yeah, you cannot know what happens on the caller side. So yeah, if the caller doesn't do anything, but in the case that I don't know, then or no, it might be legitimate even if the caller is using A.
So I have a question.
So the surprising answer is D. And I would show you a use case that you all know. This is the use case. swap. Since C+11, swap is implemented in a more efficient way than before. Did you know that moving to C+11 and doing nothing in your code, nothing, improves your performance? I mean, you are using string and vector in previous old code base, and you just move to compile it with C+11. Nothing changes, and your code is being more efficient. Why? Because it uses move whenever it can, including calling to swap. Suppose I swap two vectors. Before C+11, it would be copying through a temporary, which requires 3 copies. Since C+11, it requires 3 moves. That's it. Whoa, it's much more efficient. And if you have a swap on something, on a string, on a vector, then it becomes quite efficient. So this is how swap is implemented since C+11. You can steal from an L value as long as you know that the L value is going to be overridden by another value. So the reason that it is okay, maybe the user outside would use LHV. Yeah, he would use it. This is the reason it sends it by reference, because I want to continue using it on the caller side. Yeah, but don't worry. You just get a new value inside. I know that I'm going to put a new value inside, so there isn't any reason to preserve your old value. I can steal from it because I'm the one that puts another value inside. And in such cases, and there are such cases, here is an example. You may move something even if you got it as an L value. Why? Oh, because I'm going to put another value inside. So this is a use case.
So
it's a real use case.
Quick question. So as far as I remember, when you have a moved from object, it should be
invalidated. The word that is being used, that
it's
it is being
unspecified, right?
invalidated.
It's unspecified. It's how the standard says it's unspecified state, but it's valid in, like, you can do, let's say, dot size, and it gives you 0, for example.
It depends on the object. It depends on the object. So if it is a vector, yeah, you may call dot size and get 0. If it is a string, probably, yeah, you can do that. But it depends on the implementation, and the spec says what is the implementation for string, for vector, etc. But suppose that I don't know what the actual implementation of the move on this object. Still, I know that if I can assign to it, then it's okay. Now, somebody can say, but how can you tell that this object, the T, has the move assignment operator? I don't know. If it doesn't have a move assignment, no, don't worry. It would go to the copy. Why? The same reason as we saw here. The copy assignment, copy constructor, whatever, this signature is the fallback for all cases. For the move assignment. But if I don't have it, oh, I would go to the copy. This is fine. I can do that. So I'm willing to go to the copy.
Is it important to have my move constructor defined as no except to be able to use some of these
we will
features?
talk about no except. In this case, no except, I think, is no except required? I think no, because once you try to copy and one is being copied, and it is required for vector pushback or vector resize. On this one, this is a good question. I will take it for the vector case, and then we can think about this case.
Okay. Another comment that I just remember about the const part. I remember that it's not a good habit to return const by value, because that also doesn't make sense. You can't really move from when you return a value.
That's correct. This is new from C+11, that if you were used to return const by value, you should now return by value without the const. So you would be able to move from this thing and not copy from that. So it is better. Be cautious with passing by value. Again, the thing that we were discussing before. So there are 2 reasons why not to do that. The first reason is what we discussed about Howard Inant. Oh, by the way, this is the link to the. Oh, it was in ACCU. So the reference to Howard Inant. This is the actual talk he gave in ACCU. These are the slides. I didn't find the video recording. So again, if you use that and you want to copy, it might be that you pay for L value reference for copy and move. In some cases, it might be a bit costly. It's not so bad, but if you can do both, it is better, both the L value version and the R value. But if you actually do something which is not essentially a copy, like in this example, I get a string and I want to put it inside a set. Now, this is not a copy. This is not a get by value and copy. Why? Because it might be that this string is already in the set. So when I call insert and the string is in the set, I actually copy the string, and then insert says, "Oh, it was there." Nothing happens. Now, if I would get this string as a const reference, then I wouldn't copy or move when I call the insert. So in a way here, I copy the L value, and then say, "Oh, sorry, I don't need it." So if I compare it to the other options is to implement these two, or to implement the forwarding reference option. I would not have enough time to dive into what is a forwarding reference. I would just tell you shortly that when you see double ref on a template parameter, this one is a template parameter in the function store. Since T is a template parameter and it has double ref, it means not R value reference, but maybe R value, maybe L value, and the name for that is forwarding reference. And it was called before that universal reference by Scott Myers, and many still refer to it as universal reference, forwarding reference. So the double ref on T here is not essentially R value. It might be R value or L value, whatever is being sent. In which case it actually accommodates both functions. So I say, okay, you will get something, and then I would forward it as I got it. If I got it as an R value, I forward it as an R value. If I got it as an L value, I forward it as an L value, and forward is like stood move, but it is conditional on how did you get it. If you got it as an L value, we would pass it as an L value. If you got it as an R value, we would cast it back to an R value and then forward it, pass it on as an R value. So I would not dive into this explanation or this comparison, but at the end, if you do these were the two that we just saw, const ref plus R value or forwarding reference. These two are the most efficient because you would, with L value, pay nothing, no copy, no move. With if the string is in the set. If the string is not in the set, you should copy anyhow, or move if it is an R value. Otherwise, the other options are more costly. So be sure not to play with something that seems to be efficient enough, and then at the end pay for a copy. And a copy for a string or a copy for a container might be costly. Next one. What's wrong here? This is the code. These are the answers. I have a operator plus taking two strings, concatenating them somehow, and then moving the result outside. What is the problem? A says nothing, the code is fine. Or B says returning a dangling reference. C says a performance issue, and D says code doesn't compile.
Okay, folks, start casting your vote.
Yeah. So again, I would focus you on two things. We stood move the result. Well, it is a local, and we send it back as an R value reference.
So there is an A here. People can continue. Wait another few seconds. People can type their guess.
If it is too quick, don't worry. We are recorded. You can see it again, and then think again.
Someone says B.
And it is too quick. I mean, we don't. The proper time to give you is let's say a minute or two. But I would just reveal the answer. It is returning a dangling reference. We have a link here to the code. We have a question in Stack Overflow explaining why returning an R value is most probably a bad thing. I mean, you should not return an R value. It means that, oh, I'm returning something that is going to die. What can I do with something that you return me and is going to die? I can copy it. If I immediately copy it, this is fine. But if I take it by reference, then I take a dangling reference because it's eventually a reference to a local variable. So you should not do that.
There is a question in the chat, by the way.
Yeah.
can you also return without the double ampersand, which is the R value of?
Oh,
And is it the same
that's a
if
good
you
question.
don't have it? Oh, that's the next slide.
That's the next slide. So what's wrong here? I mean, there is still something wrong, or maybe no. Maybe it is nothing. The code is fine. Because now I say I'm returning a copy. I'm returning a copy, which is what I need to do. I mean, you cannot return a reference to a local variable, not an L value reference, not an R value reference. It's a dangling reference at the end. You can return by value. Don't worry, there might be optimizations, but what's wrong here? I do std move. Now,
Okay.
do I
So
need the
someone
std
says
move?
C. Someone says C.
And C is right. And the reason is, without this std move, the compiler is able to do return value optimization. The compiler can say, oh, you know what? I would not create it as a local variable and then copy it on the return position in the stack. I would create the local variable directly. I see, the compiler sees that the return value is this variable. So the compiler can say, you know what? I would create the object directly on the place where I need to position the return. And then I would not have to copy outside. And this is return value optimization. Now, once I do std move, the compiler says, oh, you're not returning this one, you're returning something else. So the compiler doesn't have any choice but to create the local variable, then send it to a function, then take the result from the function and put the result on the return position in the stack, which is the copy. So I actually have a pessimization. The best case would be maybe I would have a move. It might be. Maybe you would have a move because it's a local variable. I would move outside. That's fine. Maybe I would have a copy if this type doesn't have a move constructor. But if I would just avoid the call to std move, I may have something even better. The something better is I may have copy elision. Now, if you do not have copy elision, then comes another rule. And the rule is that the compiler gives you implicit move on return for local variables. Again, you get implicit move, like you get move without saying that, on the return line on local variables. This is a local variable. It would be moved outside anyhow. Don't say that, because if you say that, it's a pessimization. C++ is a funny language. I mean, you say something that would happen anyhow, and then you pay for that. But it would happen anyhow. Yes, but you just said that. I know, but you said that it would happen. Yeah, but if it happens anyhow and I don't say it, then it might not happen. And then the compiler would do optimization. So don't std move unless maybe you need to move something which is not a local variable. Suppose that you return something which is a member variable, one of your members. Okay, and you know that you can move it. Why? Because the object is going to die. There is a reason. Suppose that there is a reason. Then maybe you need a std move. So not having a std move on return, it's not the rule that I want to say. The rule is you should not have a std move for a local variable on the return. By the way, there is a link here to Compiler Explorer showing that you actually pay for that. Maybe we can click on that shortly. Let's see. So I have here a my string that I implemented that shows if I'm going through what I go through. I have here the function. This is the function, and here I'm with std move. Okay, you see that once I have std move, I pay for the move. I'm going through the move constructor. Okay, which is not so bad, but going through nothing is much better. So let's now change that. Be with me. I'm removing the call to std move. No std move. And you would see in a moment that I got no call to copy constructor or move constructor. I got copy elision. The compiler says, okay, I know I would go there. I mean, I did go to through the constructor that creates a low world, but I didn't have to copy it or to move it. You can actually see that. And if I go back to call std move, I would have a call to the move constructor, which is more than nothing. I mean, it should be not so costly. In some cases, it may be a bit costly. In some cases, it hurt your branch prediction or code instruction cache. Let's go to the next one. This is the proper way. The proper way is to return by value the local variable, and that's it. And you get implicit move on return for a local variable. What's wrong here? I have a push function that gets t. I think that t is a forwarding reference because we just discussed forwarding reference, and this T is a template variable, template parameter. Should it be? Would it be forwarding reference? In which case, using forward is good, or maybe T ampersand double ampersand in push is not a forwarding reference, and this would be compilation error. Or maybe it is not a forwarding reference, and thus we support only push on R values. Or maybe push may add to the vector a dangling reference. Oh, you're adding a dangling reference, maybe. Or maybe push may inefficiently copy when it can actually move. What do you say?
But yeah, what people think. Let me see.
The situation is that we get something as a double ref. Is it an R value? Is it a forwarding reference? We try to forward the T that we got into pushback. Do we actually forward? Is it actually a forwarding reference?
Okay, let's eliminate something. First of all, it's not a forwarding reference, right?
That's correct. It is not. Why?
Rules. I just memorized the rules. The T is not on the push. It's on the class type.
Exactly. In order to be a forwarding reference, it should be a direct template argument of the function. Now this T is being resolved already for the class itself. So when the compiler goes to push, it says, I know whose T is. I mean, I'm a stack of integers or I'm a stack of strings. I know that T is a string. So this is not a forwarding reference. This is an R value, an actual R value. In order to be a forwarding reference, T must be a direct template argument and without any addition, just T as it is. So it is not a forwarding reference. It is R value. In which case, what would be the answer? Well, I don't think it should be a compilation error because, yeah, our value is legitimate. So maybe B. Or maybe it's not C because it's not a dangling reference. I take it and I forward it to pushback. Pushback would copy. So I don't think it should be a dangling reference. And I don't see any inefficiency here because I take something which is an R value. If I forwarded it, it would be moved. It is like calling std move. Oh, I was an R value. Okay, then this is a casting to R value. So you would be moved inside pushback. So the answer is B. We actually do not allow in our stack to get something which is an L value. You would get compilation error. I'm not supporting L values. And then the user would say, why aren't you supporting L values? I have to send you only temporaries. I have something that was created before. I cannot send it, only temporaries. This is what I support. You need to create another option like these two. Oh, this is for the R value case, and this is for the L value case. And then I can just call std move. I mean, I know that you are an R value. By the way, this is what was done inside vector and list and all these that implemented push or pushback in the language. Now, if you want to implement that in a single function, then you need the template argument to be the exact direct template of the function. So U now is a template argument of the function. Okay, and I'm using U directly. Now it is a forwarding reference. And now it accommodates both cases. It would be relevant for the R value case and for the L value case. Let's continue. What's wrong here? Same stack class. We have in this stack a vector which holds the values. Now we want to pop something. In order to pop, we call back. Back returns me the value, but back doesn't remove the value. So then I call pop back. But since I know that I would use back as is, I'm taking it by reference, and then I'm moving from it. Why I'm moving from it? This is not a move on a local variable. It is a move on a local reference. Oh, you're a reference. I mean, if I would not use move here, you would be copied. So I'm trying to move. And the answers are, oh, you're returning a dangling reference, which doesn't seem the correct answer because I'm actually returning by value. So I don't know. Or B, pop moves from a dangling reference. You're trying to move from something that is a dangling reference, maybe. Why? Because code would be okay without the call to std move. It says without std move, it would be fine. C says pop as undefined behavior, moving out from a vector is impossible. You cannot move an object out of a vector. And this says that the reference E is being invalidated once we call popback. You have a reference E, and then when you call popback, oh, I'm referencing something that is dead by now. What do you say?
So people says dangling D and D.
D and D, B
D
and
and
D,
D. D and D.
which means
Dungeon and Dragons.
okay.
Um,
Yeah. So I see here that D sounds quite fair because when you take the back, okay, I have a valid reference to a live object, but then when I call pop back, I actually kill the object that I hold here by reference. Popback actually calls the distractor on the last element, which means now E is reference to invalidated object. Now it is not a dangling reference. The reason that it is not a dangling reference to be exact semantically, there is place in memory which still is held by the vector, because the vector, when you pop back, it doesn't shrink. So the capacity still holds the raw memory, but it is raw memory. I mean, the object that was represented here was distracted. I actually, refer to something, but the something is a dead object. So I'm the D is the most correct answer here. Here I call the distractor. So the question is, how can I do it more elegantly? I mean, this is not so elegant. Well, you can call back. Then you have to move while it is still alive. Now I moved into E. E is a new one. E is not the one that is going to die. E is a new one. And now you do not have to move because this is a local variable. You had to move here, and now you can call popback. It's quite delicate, you see. I mean, this seems fair. No, it is not. And by the way, in many cases it would work. Why? Maybe the distractor that was called here, just called distraction on some allocations, which are still there. I mean, when I access them, oh, nobody still use this heap. So in some cases, I would use things here and it would work. And then in production, it would crash. So it is quite delicate. And this
do
is
you
the
know?
correct one.
Do you know if there are tools that, like, would sanitizer
Yeah,
or
sanitizer would catch me here.
would catch it? Okay,
Sanitizer should catch me here, I presume, because I'm trying to do something with E, and sanitizer should see. It depends on the E. Suppose that there is an int. If the entire thing is with integers here, the sanitizer would not see that because it was only a distractor call, which does nothing on an integer, and the raw memory is still there. But then if for some other case I use here string, then sanitizer would catch me.
got
Okay?
it. Yeah,
Because a distractor was called and doing something with the object, like trying to call a copy constructor or a move constructor on a dead object. But in this case, if it is trivially copyable or something that doesn't have a distractor or doesn't have any internal allocation, sanitizer cannot see that because of the capacity of the vector. A side note: implementing move, forgetting no except. If you implement move and we forget to put the no except, then the explanation is here. I would leave it here and you would read it. It would copy instead of move in case you're using a vector. So if you're using a vector and pushing to the vector, at a certain point, the vector doesn't have enough capacity. Then it has to be enlarged. A new capacity is being allocated, and all the old objects need to be copied from the old allocation to the new one. Now, the vector can either copy or move, and the vector decides. If the move says that it would not throw an exception, I would use move. Otherwise, if it doesn't say so, I would use copy. And there is a reason for that, because with copy, you can roll back because I still have the old one. I just copied. With move, you cannot roll back because I moved from something and, oh, the old one is invalidated. So if an exception is thrown, I cannot go back to the old one. Oh, it is being distracted in a way. So it would say, oh, if it doesn't say no except, I would copy because copy is more secure because I still have the old allocation, which is bad. I mean, a move should never throw. You should not have throwing move implementation. I cannot see a reason for that, in which case you should have no except in order to move. And vector is a very classic example. You can think about other examples. Swap. We need to think about swap, whether swap can use move if move throws an exception. I have to check that. It's a good question. Last one. Be prepared. Are you ready? It comes. Okay. What's wrong here? I'm implementing a max function. I'm getting A and B. I'm checking whether B is less than A, in which case I would return A, otherwise B, because I got it as an R value or L value, a forwarding reference, a universal reference, as Scott Myers coined the term. Then I use stood forward. Now, the same issue would happen if I would be using stood move on an R value. There aren't any multiple choice here. You should say what the problem is.
So since T is just a T, it's not a reference, not R value or L value, there gonna be some construction happening or return value optimization, maybe. I don't know.
Calling stood forward on this argument is okay. Why? Because it depends on the version. I think that since C++ 20, it is okay if you do not do move on an R value argument that you got. But before that, the implicit move on return was not including R value argument. Anyhow, I'm doing a stood forward here because I want to make sure that I would move outside. So I'm not worrying about any pessimization. I'm worried about something else. And the something else is that eventually you cannot forward or move more than once. Once you moved or forwarded, it means that B was used already. You cannot use B again. So if you forwarded here, you cannot use B here. In which case you should not forward in the call to the smaller than. By the way, you can ask, is there any reason for smaller than to behave differently for R value and L value? I don't know. I cannot rely on that. But anyhow, I cannot do the move here. Why? Because I still need A and B there. In which case, I would keep only the forward on the last one and not on the first one. I can give you an example where it doesn't work. I mean, I can actually cook an example where this would be undefined behavior. In cases where, oh, the smaller than operator was implemented intentionally in a way that it steals if you are in R value. Oh,
Yeah.
you are in R value. I want to do something and I would, just invalidate you because I can.
Right.
Why?
Yeah.
Because I can. Oh, it may happen. In which case B is invalidated because it was sent as an R value. You should never do a forward or a move on something that is being used later on. Oh, don't do that. Okay. By the way, you should never use stood move or stood forward in a loop. Same case. It means, oh, in the second iteration of the loop, I'm coming to the same variable and I'm moving it again, unless it is on a different variable. Suppose that it is on range-based 4, and I do that on the variable in the range-based 4, that's okay. But if I'm doing it on the same variable again and again, oh, don't do that. If it's the same variable, or it might be the same variable, it was moved already. I cannot use it again in the next iteration. So be very careful with that. Let's
I
summarize.
wonder if there are
Yes.
any tools that actually either tools or Chat GPT can can help with that.
So in this case, static code analysis didn't get on that. This is the
Okay.
example. In this
Okay.
example, I'm doing this exact bad thing. Okay, the link is in the slides.
Yeah.
And
Yeah.
I
I can see that.
implemented intentionally. I implemented the smaller than with, oh, I want to steal with you from you. Why? Just because I want. I don't know. I'm allowed. And then eventually max is nothing. Max should be something, it is nothing because something was moved twice. You shouldn't do that. I think that if I would add here minus f sanitize equals address, would it catch that? I'm not sure. No, let's add undefined sanitizer for undefined behavior. And I'm not sure that we have undefined behavior here. I mean, you should not do that, but if you do, static code analysis tools should catch you.
you need Rust here to catch it.
Or
you need the bow
yeah,
checker.
that's correct. That's correct. But even in Rust, yeah, in Rust, nobody would do that because it requires to go through unsafe,
Yeah, right.
and then people are more, careful. I would say that the rule is very, very simple.
Yeah.
Don't move or forward more than once. And if you do that only on the last usage. Very simple. Okay, so let's summarize. Don't std move anything without thinking. Don't std move local variables on return. Why? Pessimization. It is better not to do that. Don't move something that is still in use by you or others, like in the next statement or in the loop. Don't move something twice, which is the same thing as we said before. On the other end, don't waive std move when needed, because then you would hurt performance. You should std move an R value that has a name, and you know you won't be using it anymore. You can also std move L values if the mood value would not be used. I mean, I know that I'm going to override you. I know that for some reason nobody would use you. These are all good reasons. So yeah, a bonus slide. We would not have time for the bonus slide, but I would just tell you that since C++ 14, you may move into a lambda. This is the way to move into a lambda. And since C++ 14, you can have a lambda with auto. Since C++ 20, auto can be a type also for a function. And then if you want to forward, you need the actual type, and you don't have it because it was auto. You can still use the declare type of S and use it inside the forward, because forward should get in the triangle. Move just moves. Forward says, oh, I'm conditional. I need to get the original type inside the triangle brackets, and this is the way to do that for an auto R value, auto forwarding reference argument. And that's it.
Thank you.
Greetings with forwarding reference. These are the two emails, one for comments and feedbacks. And if you suffer from slow builds, if you want to speak with me about, can we do something to accelerate my entire CI pipeline? It might be C++ builds, it might be unit testing or anything that takes much time and can be distributed. Shoot me an email to this email address. Thank you all. I'm here for questions.
One question, can you go to slide 30 or 30, basically the returning of move reference with the
Sure.
operator plus? Go back,
This one.
back. Yeah, not the one above, but two before, I think. Yep.
The
Still
one
go
that's
back.
that
No,
should move. This one.
no, go back.
This one.
Yep, yeah.
Okay.
So over here, what's wrong with why it should be a problem if we are calling with operator plus? Because with operator plus, can we call operator plus such a way that it is not in a sentence or it is not in a basically in a statement, and it will be returning a dangling reference? Because you will be using right away, right? In the same what do you call, the same instruction, basically you'll be using it.
Yeah, I think that I was not so exact when I said that if you are copying immediately, then it is okay. I think that even if you are trying to copy it immediately, then the reference that got out is a reference to a local variable that is being
I agree
fed.
on that part.
So in which case it is always bad, even if you try to copy it immediately. I think that it resembles returning a pointer to a local array. Suppose that I create a local rectangle bracket array, a local C-style array, and then I return the pointer to the beginning of the array, but the array is local. So this is a pointer that cannot be used in any way outside. Now it might be that you use it and it works. How? Because the stack folded, but the memory still has the value.
But
Same here.
Isn't it same like moving L value? Basically, you should not, but then it just works because the way you are using it.
Well, again, it just works means that the stack folded, and the local concat is not there anymore. I mean the cursor, the stack folded, the position, but maybe it is still there. But might be that when I get it out for some reason, something is writing on that position. So I can open this is the program, and we can play with it. You see that the program here crashed. Let's see why it crashed. It crashed because I took the value of the plus, okay, and I'm trying to copy it. Let's see what happens. The plus is implemented as now. I'm implementing the plus by just calling plus. You can ask, how can calling plus be the implementation of plus? Because I'm a bit cheating. I'm saying, okay, you know, my string is just std string, but I still want to play with it. So I'm saying, okay, I would implement plus by calling the plus of string, so I don't have to, you know, implement how concatenation works. It's a bit complicated to implement that, but I do return as R value reference. So in a way, I'm returning an R value reference, which is a concat, okay, which was born here. But then I would tell you why in this case it actually crashes, because when the stack unfolds and this object is being dead, it is not only that it is above the stack location. The distractor was called. The distractor on this object was called when I got out. So I'm trying to use a reference to an object that was distracted. And then, you know, here on that side.
Okay, got it.
And then I crash. So the bottom line is that you would rarely see a function that returns R value. I mean, there is a reason to return L value reference. I can tell you the reason. Suppose that you want to return, it's a bad design, usually. But let's assume that you want to return reference to a member. And I say, okay, I would return it as a const. I expose my internal structure, but it might be, you know, for some reason, okay, it's inside the module. You can see my design. I return a const reference to a member. Okay, that's fine, as long as it is an L value reference. Once I see R value reference, what are you trying to expose here? A reference to something that is dead, that is going to die, actually dead. So this is quite rare. And if I go back to the slides, there is a question in Stack Overflow. Is there any use of returning an R value reference like that? And the answer is not necessarily. Our Dinant is the one answering that. Let's take a look. This is the question. And then our Dinant says, yeah, but like for a move iterator, for example. This is our Dinant. So yeah, there is, but in very specific cases, in most cases, no, you would not need that.
Yeah, I got it. Yeah, thanks, Amir.
Kobe, you handle the time. You know, if we have still time for questions. I think that I just, you know, destroyed. I wanted to hear about polymorphic arrays. I don't know if
That's fine.
anybody
We'll
else.
do it next time.
Next time.
Thank you so much. I have another, just a small comment before we end up. I just want to make sure people know that if you want to have your default move constructor, for example, or at least the move constructor, and you assign default. Basically, you want the compiler to create the constructor for you. It is, as far as I remember, no except by default if you just have equal default. So you don't need to worry about that. That's something that I remember when we discussed about no except. I don't have anything else. Is there any other question that people want to?
I would just say that it is a no except by default, as long as the destructor of all your members is no except.
Right. True.
Which is exactly what you want as well, because if one of my members may throw an exception in its move operation, which it shouldn't, but then again I want to emphasize, because it was a good question. I'm very happy about this question, because I wasn't so exact and it bothers me, but I continued, and then the question took me back. This thing is undefined behavior and dangling reference, even if you copy it immediately, as we just saw. Okay.
Mm-hmm.
In some cases, you can take something and copy it immediately, but not here. So I can, you know, create another case where I say, okay, it's not an R value to a temporary or to a dead object. This case would never be okay.
I had a question about the double move. Like, when you've done a move, isn't the object that you move from supposed to be in a valid state? So can you not do? I mean, I don't know why you would want to move out of something that had been, you know, do a double move, but isn't it still like it's not going to crash or do anything nasty?
Well, in the example that I gave, it crashes. Now, again, I cooked the example. This is the example. I cooked it so it would crash, but usually when you do stood forward in this example, you deal with a type that is generic. You don't know which type would get in which case it is very risky to say, oh, I know that this is fine. If you come up with a type that you say, okay, I can move it twice, but then I cannot see the use case. I mean, when I move something, it was invalidated. So moving it again is just trying to do something with an object that was moved already. It only has, the garbage or the leftovers of something.
But you're not supposed to leave it. Can you leave it in an undefined state after you've done a move, though? I mean, you certainly need to be able to call the destructor after you've moved out of it.
The specification doesn't say. The specification can only refer to objects which are in the specification, like string, vector, etc. Okay, so if you moved from a vector, the specification says something about what you can still do with the vector after it was moved. And Kobe, remember that you can check its size. I don't remember. We can go and check that. This is a good question. What can you do with that? There are certain operations that, still I can't ask you, and you would say that your size is 0. Okay, it might be. Anyhow, it doesn't refer to any other object. You can create an object that after it was moved, I mean, after somebody took it and moved its assets, maybe any call to it except for overriding. Overriding means, okay, I put another value into this object, but any call,
or
any
calling
dot
a destructor,
would
or
crash.
calling a destructor, presumably. I mean, you've got to be able to destroy it.
Something like that. So do you have to be in a valid state after you are being moved from? The answer is it depends on the implementation. There is being in a valid state, but it's not something that you are obliged to as implementer of your class. It is nice, but you cannot know that. But then again, you are invalidated in a way that moving again from the same object wouldn't do anything, which I can see reasonable.
Yeah, so I actually Googled for that specific. So it's not an undefined behavior to call size, but it's not like it's guaranteed to be 0. It's just unspecified. So it's not an undefined behavior. It's actually defined to give you something, but it's useless.
Right.
Okay. Which means
makes
that
sense.
Don't call size on a vector after it was moved.
Yeah.
I mean, it is implementation specific.
Right.
I think that on string, it does say something. On string, maybe it says that there is a difference between string and vector in this aspect. Kobe is checking for string.
I'm checking.
But in any case, you should be very careful with using an object after it was moved from. It means that, it was an R value or a temporal or something that I decided to use for another object. And then the old one is just, it's an empty vase. I can put new things inside by assignment, but nothing else.
Nothing else, yeah.
Like, for example, for unique PTR, I can tell you, after it is being moved, you can ask whether it is null PTR. It would be null PTR. You can ask dot or not. You can ask not. So not operator in unique PTR, which was moved from, would return true. Yes, I'm not a pointer, which means I was moved from, or I was not assigned. I was never assigned, or I was moved from. But for unique PTR, it is defined like that.
So Amir, you are right. In basic string, at least for lib C++, which is the C++ standard library that is shipped with Clang. So we have lib C++ and lib stud C++. People should probably familiar with that. So it's actually zeroing it in the move constructor. It's zeroed the string, so there is a. I think
there is a defined behavior, right. But again, you say that it is implementation specific.
I see it in lib C++. So
you see it in the code.
Yeah, I see.
You went to the code. I think that
so.
Maybe the spec says something about string. I think that there is a reason that the spec says something about string. It doesn't say it about vector. I don't remember the reason. But anyhow, before you do anything that relies on the values that would be inside an object that was moved from, check.
Yeah.
Check what the spec says, or check what the documentation of that class says.
Yeah. It's like running with knives. I wouldn't do that.
Yeah. or with a fork.
No, I learned this terminology from a last podcast from Connor of the ADSP podcast. He said something like this, and this sounds. Okay. Any other questions, people on the bridge? Okay. No. So thank you, Amir. It's amazing talk. I would like to just tell people that this is not an easy topic, and I think we learn a lot of things here that would help us in our daily job. And thank you so much, Amir, for
Thank
that.
you all.
So
And
you have the contacts of Amir and the product, and Amir himself is available. So thank you, Amir, for that.
and you will get the slides. I will send Kobe the slides so we can share it with all. And also, I think we had only one example that we wrote. Oh, we have a few, but I think most of them are examples. This is from the slides. I would not share it because it's in the slides.
Yeah.
This is also in the slides. This is also in the slides. I think that the only one that we implemented and I want to share is the initial one that we did for what Move does, and this is homework. Anyone who says, oh, I'm not sure that I know how to implement that, you should. Now, usually I would tell you that, in most cases, you should be in no user-defined copy, constructor, move, destructor, etc., which is the rule of zero. Most classes should be in rule of zero. But in case you do have any assets, any resources, then most probably you are in rule of five. I want all five. And then you need to know how to implement all five, either because of allocations or any other resources.
Thank you. Thanks, everyone. Thanks, Samir. Have a good night. Take care.
Bye.
Bye-bye.